We will be demonstrating and explaining the vertical free fall formulas for an object beginning at rest, neglecting air resistance. In order to translate these formulas into a measurable experiment, we will be measuring the time it takes for a foosball to travel 1 meter from rest.
After averaging our various trials, we found the time it takes for the foosball to travel 1 meter to be 0.447 seconds. The motion of the foosball can be defined by these four formulas. Vf equals Vi minus Gt, Vf squared equals Vi minus 2g delta y equals Vit minus 1 half Gt squared, and delta y equals 1 half Vi plus Vf times t, in which Vi, Vf, delta y, t, and g are representative of initial velocity, final velocity, height, time, and gravity respectively.
In order to be able to prove these formulas, the value of velocity final must first be determined. By plugging in all known values into the first equation, the approximated value of velocity final can be determined to be negative 4.381 meters per second. This value should be negative as the object is accelerating in the negative y direction.
Using the average time of 0.447 seconds, we can prove the validity of these formulas by plugging in all known values and calculating the percent error achieved by our experiment. As the first formula was used to obtain the value of Vf, it can be omitted in these calculations as it would have a percent error of 0%. By squaring the value of Vf to get 19.190 and comparing it to the value of Vi squared minus 2g delta y, or 19.600, using the percent error formula a minus b over a times 100, an error of 2.094% was calculated.
This process can be repeated for the third formula by comparing delta y, or negative 1, to 1 half Vi plus Vi times t, or negative 0.981, and plugging it into the percent error formula. As using negative values would yield a negative percentage, the absolute value of each component can be used to obtain the percent error of 1.900%.
The comparison of delta y, or negative 1, and Vit minus 1 half Gt squared is negative 0.979, which corresponds with a percent error of 2.100%. These relatively low percentages are indicative of accurate data collection and elimination of human error. However, it would be impossible to obtain an error of 0% as this experiment was conducted in ignorance of air resistance.
A real-world example of these properties of freefall is Red Bull's stunt with Felix Baumgartner, in which he skydived from a height of nearly 40 kilometers. During his freefall, Felix reached a velocity of 1,357.6 kilometers per hour, or 377.111 meters per second. Using the formulas for an object in freefall would yield extremely inaccurate results, as they do not account for the effect of air resistance on his descent.
The effects of air resistance in this stunt can be observed by comparing the theoretical final velocity of Baumgartner to his actual final velocity using the same percent error formula. His freefall lasted just over 4 minutes, clocking in at 264 seconds. Using the first freefall formula, Baumgartner would have reached a velocity of negative 2,587.200 meters per second in the absence of air resistance. This large disparity is equivalent to a percent error of 586.058% and comes as a result of the poor aerodynamics of the human body.
Safely to do